What's up, people? Let's tune an HF antenna for 40 meters. And here's what I got so far. And as a disclaimer, I'm new at this. This is all new material for me, new experiences. So I'm just like you guys. I researched everything on the net and some pamphlets, books, you name it, field manuals and whatnot. And this is what I got so far. For NVIS, I want to operate in the 40 meter range. I got my home set up already for that frequency and an antenna as well. Now I'm tuning my field antenna, which I'm going to take out to the field. I'm using this dipole antenna, and this is one half of it. Right now is 34 feet long from this point to the very middle. So overall is 68 feet long, roughly. And what I have here is WD1 military field phone wires. And I have it with this Dyneema setup here with a loop here, and then onto paracord, which I have a trucker's hitch onto the kids' playset here. This is not my optimal height. For my operating conditions, it should be 9 feet high off the ground. Right now we're looking at maybe 5, but for tuning purposes that could be okay. It's not going to change the resonant frequency of the antenna. What it will change is the input impedance of the antenna. And let's go right to the middle. Here I have the middle of the dipole, and this is my input to this antenna here, my transmission cable. I got a little piece of ladder line here. Then within this tape here I have a little balloon that converts unbalanced transmission line like coax here to a balanced transmission line, which is this ladder line here, and it goes into this dipole antenna, which is a balanced antenna. So you have your positive end going that way, 34 feet roughly, and 34 feet going that way for the negative side of the antenna. And of course, with the waves going in there, it's going to oscillate back and forth as far as the negatives and the positive. No need to go there. And here I have that same Dyneema right in the middle here that's supporting. It looks like one piece of wire, but actually there's a break right here. This side is totally isolated from this side, and I have like this continuous Dyneema going straight through, and the wires are sandwiched between those two lugs there for both sides. And then I have the ladder line with some butt connectors there and an eye loop connected to this banana jack banana jack adapter here, which is perfect because if this line here ever breaks, I could always hook up another piece of wire to this lug right here. So it's field repairable. I could always scavenge some wire somewhere along the trek. Here I have my 1-to-1 balun, and this cable here was actually cannibalized from my Slim Jim or Jim Slim antenna. It just crapped out, but I kept the one side of it because it has a UHF female connector there, and I left the RF choke on there since it was already installed on the braid of the coax cable there. And then on the other side I got the same thing. What you see up there is a marlin spike, and it's holding up pretty well, and going around the tree is a Siberian hitch knot. So it's kind of like adding a little bit of bushcraft to electronics, which it's right up my alley. So like I said, the length of this whole thing, on one half of it is 34 inches long, 34 feet long and some change. It's got to be 33 feet and 3 inches long to resonate on the frequency that I want, according to the formula. But there's other variables that may change that slightly more or less. the kind of transmission line, closeness to other metallic obstacles, and all sorts of stuff to kind of change the resonant frequency of this wire here. So even though you may do it perfectly well on paper, it may not come out to what you're expecting. So it's best to go a little bit long on the wire, then tune your way backwards to get into that frequency range. And that's what I've done here. But it looks like I'm resonating at 6.46 megahertz, and I want a 7.03. And if you do the math, it really doesn't come out to 34.6 feet. It should be a little bit longer or shorter, one of the two, to resonate on that. So like I was saying, the length of the cable could be a factor. My balun interface there could be a factor. There could be little factors there to do that. So on this end here is where I'm going to start to trim. So this point right here is 33 feet. Another 3 inches. My resonant frequency should be right here. So I'm going to go ahead and cut it right here, just a little bit forward. I'm going to save this piece and cut the exact same length on the other end of my dipole. So I loosened the trucker's hitch on the other end and dropped the whole antenna down to the ground. And here's the other end that I want to trim off. So here I have my cut piece from the other end. So theoretically I should cut the same length on this end to keep it all equal on both sides. It has to have the same amount of length on each side of that break in the middle of the transmission line, the feed point. So I'll just match these two up like so, as close as humanly possible, right about there. And here we cut, looks like maybe 5 to 6 inches worth of length here. Remember, I started off with 34 feet. I have to go to 33 feet according to the math. But the math, like I said, doesn't sometimes match up with real life. So here on this end here, I'll just put enough slack here to the very end of where the wire will sort of disappear into the braid, and I'll just keep it there. I want to keep it out just a little bit so I could grab onto it a little bit later if I need to trim it down any more than I have to. And right there it looks like it's going to hold. And I'll apply some pressure. You can see that it's showing just a little bit outside the braid. And once you get done with your length and everything, you could bury that piece of wire right into the Dyneema braid, keeping everything perfectly straight once you deploy your antenna. So I'm gonna go to the other end and loft up the antenna once again and measure again. So there you see the frequency did go higher as far as resonance. Let's see what that measures now. 6.54, not that much, but we're gonna go further. It looks like I'm gonna go less than 33 feet of length as far as how the pace of this is going. For some reason it's showing a little bit lower length than so that would be the antenna is either inductive or capacitive in nature. But I want to use this antenna without using a antenna tuner, just to keep it lighter in the field. And plus the only tuner that I have is at home. So I'm going to continue this without filming there. I hope you get the picture of what tuning this antenna is all about. You first start off with a higher length, longer length than what you needed, because it's easier to take away than to put back in as far as the cable itself. So I'm going to go ahead and continue with the rest of this to get it to the resonant frequency that I want. All this tuning, that's pretty much what it came down to, is lopping off all these wires from both ends. This is when I started. Then I measured, cut, measure, cut, measure, and as I was getting closer and closer to my desired frequency, I made smaller and smaller cuts until I was right on. And I finally ended up with something like this. So doing the math on paper, it says to cut for 33.3 feet to get my resonant frequency of 7 megahertz 0.030 kHz. Well, it didn't turn out that way. It's actually down to 32 feet and some change. So I had to cut 1 foot shorter than what the math said on paper. If we go over to Spectrum Analyzer, there it is, 7.030, that's 40 meter band on technician class, CW only privileges, which what my radio is tuned for. And there's the resonant frequency of that particular cut that we just did. So the return loss on my resonant frequency there is minus 24.2, which comes out to roughly 1.13 SWR, or standing wave ratio. That's what you amateur geeks like to refer to this mostly. I'm still in the return loss way of thinking. So that means this is going to be a pretty good, efficient antenna as is. So the proof is in the pudding. Here's my CW radio with my preloaded information in its memory. The power supply, this is providing 12 volts to this, which roughly will give me 7 to 8 watts worth of power coming out the antenna. And here's my meter, my trusty Bird 43, and it's hooked up to my antenna, my field antenna. So I'm going to go ahead and transmit the sequence, and there's my power out. Right now it's registering 2 watts. That's because I don't have the proper slug for this. This slug is for 25 to 60 megahertz. I need a 7 megahertz slug, which I don't have yet. But I just want some indication of power out going this way. Now, the proof that's in the pudding is my reflected. So I'm going to turn this. I seen that there's 2 watts coming out. Worst case scenario, 200 milliwatts. I should get no more than 200 milliwatts. So that's like 2 ticks over on the needle here from 0. If it goes past that point, this antenna is inefficient. So I'm going to go ahead and transmit right now. There it is. It's transmitting. That needle is not budging. It's not moving at all. I have practically no power going back into my radio, meaning that all the power that's going out is being radiated out off my antenna out to in free space now, for the most part. And that's without using a tuner. That's the whole idea. This is my field antenna, and I want this to be cut to that one frequency so I wouldn't have to haul out more gear like an antenna tuner for HF. So it looks like I've succeeded with that. I got my method down. This lightweight sort of hanging material there and everything is working out just fine over there with the paracord and Boy Scout knots or whatever. That's working out fine. And if need be, I could field repair this with another piece of wire if I need to, if the wire does break for whatever reason. This WD1 wire is holding up superbly. I put a lot of pressure on this to make it nice and straight, and or tension rather, and it's holding up like a champ. So it looks like my field kit here, which is pretty much that, and this setup here, I'm field capable now, and I can hit the road. So there you have it, my field kit. Of course, I'm going to use a smaller diameter cable for my transmission cable going from the radio antenna and all that. Power pack will be the same. There's my antenna all coiled up, all 62 or 64 feet of it, and cordage to string them between 2 trees. So there you have it in a nutshell. With this, I am field capable now. I can hit the road and start installing this stuff out in the real world. The antenna height from the ground, it was around 5 feet, but according to documentation, I should be 9 feet above the ground for NVIS operations. But as far as tuning, 5 feet was okay. It's just the impedance, feed line impedance will be lower, so we will have a mismatch there. But as you can see from the test results, it was transmitting just fine in without no reflected losses. Tuned the antenna perfectly to the operating frequency of this box here. This only transmits one frequency, which is fine for my going out to the field testing purposes. Obviously, if I need more flexibility, like a tunable radio, then I would need an antenna tuner to tune the antenna. So all those cuts I made with the cable, with the clippers, it will be done by another box, which I'll show you here in a minute. So now I got the field set up. This is my home setup. There's my transmission line, ladder line, 450 ohm ladder line, 14 gauge, going over that way. And the ladder line is 81 feet long from here to where the antenna is actually at. And that length actually is critical depending on what frequency band you want to use. It's a whole lot of math and paperwork out there and research for you to figure out why that is. And then it goes into this balun right here. You see, the balun I had in my home brew setup is made for low power, no more than 15-20 watts. This one is capable of a lot more. I think at least 1500 watts. Like I said, this is my home unit here, so I figure I may put a more capable radio here at home in the near future. So I went ahead and got the big boy here to accommodate that. But it's the same as my little balun that I have built into the cable over my field kit. So it's practically the same thing, but better wattage handling on this guy right here. So here on the tree, I got a Marlin spike hitch right here at the base, and it's adjustable because I got all this line left here. And then it goes up to a pulley that's bolted into the tree there. So it's on a pulley, and there's my one end of the dipole there. I don't know if you could make that out, but I have a tie wrap there as an insulator, then the loop, then my constricting dyneema cord, and it heads over that way. Here I have an eye bolt here and an eye bolt there. I could go ahead and drop the antenna from this location here. And here's the other end of the dipole right here. There's a bowline knot there, tie wrap for an insulator, and here's my dyneema. And the wire is buried within here, keeping it nice and straight. And there's my wire going across my wood pile. And here's my center feed line there. So it's actually severed right here in the middle. One part of it will go down this end, and the other part of it will go on that end of it there. And I have a tie wrap and a little bit of tubing there to separate the two lines there. And it's working out just fine for a home unit. This is my home antenna right here. Nothing fancy. I like to be a minimalist when it comes to this type of crap, and you can't get any more minimalist than this. And it's working out very well. And I could drop the antenna anytime I want for maintenance or replacement, which I actually did have to do once already because I cut the antenna a little bit too short because it wasn't tuning right. So I just left it at its mathematical length according to, you know, the formulas, and use an antenna tuner to bring me into the frequency that I want to operate on. So this is for 40 meters. And why didn't I go crossway this way instead of going this way? Because this orientation is north and south. This orientation is east and west. My radiation pattern with this antenna here, this dipole antenna, is going north and south. So I could go way down south, hopefully Los Angeles area up to the Chico area or Mendocino County in California. Since the state of California sort of has a elongated shape to it, to the west of me is the ocean, but I could probably still reach the coastal area with this orientation. And then on the eastern side is the mountain range, the Sierra Nevada mountain range, and then Nevada and the desert. My most likely route of approach, or where I will be operating in a real thing, I would imagine, would be a north and south orientation. So I have my maximum radiation pattern going north and south, even though this is somewhat of an omnidirectional configuration. Some of that signal is going to be elongated. It's more like an elliptical sort of pattern instead of a circular omnidirectional pattern, according to the books. That's why we're going to hit the road and see what is actually going on. This is all theory. We got to hit the road to prove this shit for real. So at home, I'm going to set up a little listening post with my SDR Play receiver here and record the results. I'm going to have some software on the laptop or some other PC that would actually record any noise coming out of the receiver, timestamp it and all that good stuff, and also a sort of a what do you call it, a CW decoder to kind of decode my message being sent out there to correctly identify that yes, that was my transmission going over the air. And of course I'm going to synchronize with my field notes to find out exactly what time did I actually transmit and do all that stuff. So that boring stuff I could do on my own here. It's going to take maybe a couple of more weeks for me to set that up, and then I'll be field capable and ready to play out in the field and see what all this is all about. Alright guys, that's what's going on. I'm almost out the door with all this crap here, and we'll see you out there in the field.